Okay, thanks. Today is, let's say, the topic is the Modbus, and where we'll go into the deeper and more about the network and how the communication is working. And of course, we will talk about general things like how in general PLC and SCADA are connecting with each other and how the adversaries can abuse the Modbus. We will see it also. Okay, first of all, where to start? Here we have GitHub repo with in the main page there is all the information about the Labshock, how to install it and how to use it. And the main thing is here in Wiki there is a quick start guide where you can find how to install it and how to use it with all these services like Portal, PLC, SCADA services. Next one is, here is also the links for all the configuration guides, all the services. The second one, what we are talking today, this is Modbus protocol, a lab I created, and probably 90% information are existing in this lab. You can find it on LinkedIn in the leveling guide, or I will put the link here also into this video. The only one thing what I want to show you is some theory is about the setups what we are talking today. And yeah, I forgot, you can write your questions during the presentation, and after that we will talk and I will answer to them. Yeah, and what is Oilsprings? So this is our main area where we are building all these things. So this is the virtual environment that represents the oil station. Why? Because I'm pretty better know oil than electricity grid. So this is why I created this one. And what we have in this oil station is the simple, but in general, oil stations are simple, and we have the process where we have input as some flow going through our station, and we have two main pumps which are control the pressure. So we need to increase the pressure to our outlet will be more than input. Yeah, this is pretty simple, but it's can show to you, to all of us, how we can check the Modbus to increase our knowledge and to maybe think about how to protect this system. And today we have this network diagram, physical network diagram, where we are connecting. The first one is the PLC, so it is the 2.10 network, so it is level 2. I'm not go deeply into the Purdue model and the network segmentation by Purdue, because in most of the cases it's unique for the OT environments, and today it is very, let's say, mixed up when you have 2.5 levels, 3.5 levels, and also now the DMZ is creating. So in our case, we have L2 switch, which are, let's say, working with the MAC addresses. And here we are connecting the PLC, so this is our level 2 with 2.024 network. And we have L3 switch where all our, let's say, main systems like SCADA system, engineering station, and our pen test station are connected. This is the 3.0 network, so all these are here. And in level 3 switch, we have the routing, IP addresses, TCP, UDP, all this, let's say, all this what we have in general in the networks. And what we are doing, we are sniffing the network traffic inside our communication through the SCADA and the PLC and checking what is happening there. So this is 1.6 version of the Labshock where we have these core systems from the level 3 and level 2. And yeah, we are not go deeply into the network and go how this PLC can be segmented or whatever, because in general it's not needed for people who are jumping into the OT or for OT engineers who wants to learn the security. And another thing is a logical diagram where we are drawing what we are learning. For example, for today, we are saying that our SCADA is communicate to the PLC through Modbus TCP protocol. And this is exactly the main focus, what is happening inside this network. And of course, the red line, the Modbus TCP, which are going from the different system, because Modbus has no security, it's open, and any client with Modbus can connect into our PLC. Yeah, this is all the information is in this lab, so you can read it and check. And we can go into our Labshock portal. So all the main services are located into the local host. When after installing the Labshock, you are going into the local host. And what we have? First one is the SCADA service. So this is what the operator of the station is see 99% of his time during the shift, during his working hours. And here we can see the pretty much similar diagram, technological diagram, that our flow starting from the in, let's say we have some temperature and we have some pressure that is coming from the left side. And it's go through the dirty filters. It's not necessary for now, yes. And it can go through pump 1, if it's working, of course, and go through the pump 2, go down and go out with some increasing pressure. So input is 1999 and the output is 3 and something. And all the system, the process is about to increase the pressure and to make it 24 hours, 7 days per week, all the year. And of course, when we are enabling the pump 1 with some speed, the pressure is increased at the output. And with such manipulation of the pumps and the speed and other things, we are trying to make the output pressure exactly the same what we need. And how this SCADA, it's like, say, user interface connected into our PLC, our brain. So PLC is the brain and the SCADA is our eyes. We are going into our PLC, and inside this we can see that first it is running, and inside this PLC is running some program. Which program? It's it's really not so important, but it's running some program and create some calculation and manipulation with this data, which PLC has. And PLC is also pretty much simple. It has some inputs and outputs. So here, for example, pump 1 start, it has some address, and with Modbus, we will see a little bit later how all these addresses are connecting with each other. And it has some states, for example, true or false. And for example, now it's true. This one is a pump start. So if the operator pressing the pump switch off, it is going into the false state. And that's all. So from the SCADA, we are controlling the PLC and can start or stop PLC. And of course, there are different variables, let's say different tags, which are storing inside the PLC. And the question how the SCADA and anyone else can manipulate with this data. And here is coming this Modbus protocol. So Modbus for our lab and our communication is only the protocol that enable us to talk with PLC, like to have an interface which we can manipulate it. So it can be Modbus, it can be DNP3, for example, or Ethernet IP server. So it's no matter which protocol you are using. The main thing is that program is running inside this PLC with real time, without any issues, without any delays. And we are controlling it through the Modbus. And how it's connecting to our SCADA. So if we are going into the connection tab, so we have SCADA and it connects into our PLC. And exactly here we are putting the Modbus TCP. And this is the main thing, how we are connecting to this PLC. So we are putting Modbus TCP, we are putting the connection option, TCP port, and the IP address. So it's more or less everyone familiar with IP addresses and the port. So here port is 502, it is a standard Modbus TCP port. And when we are putting this information into the SCADA, we can say that SCADA knows how to talk with PLC. And second thing, we are adding exactly the same tags from the PLC into the SCADA. So we have exactly the same pump 1 start, and it has address. In the Modbus, if we opening here, it is a little bit different addressing. Addressing is the same, but the representing of the addresses are a little bit different. But in general, there is 4 states. The coils, this is the true or false Boolean variables that we can store only 0 or 1, for example, pump start or pump stop. This is coils, and coils has 2 variations. With read-write, it's more about that we can write the 0 or 1 into this coil, into this input, or it's only for reading. The same is going into the registers. So we have 2 types of the registers. One is for writing, another is only for reading. And that's all. So 4 types. In PLC, there is a little bit different. Let's I will show you. It's a little bit different. It's about QX, IX, QW, or IW. These addresses are described on the Open PLC project, so you can go there and check the addresses, etc. So it's more or less specification for the products, for vendor. But for our learning, it's more easier to talk about coils and talk about registers with read and write. So yeah, one more time. We had coils, which you can read or write, 0, 1, you can read or write, or you can some speed or temperature, which you can also read and write. And when you fill all these addresses, you can get some numbers which are going from the PLC. And what problem is? The problem is that if the SCADA can read this data, you can also read this data from any PLC from the network, which can connect or have a routing to this PLC. Yes, and let's check first the normal operation, which the operator is doing. Let's open the, and maybe one more thing about engineering workstation, 2 minutes only to show you how this program is created and how it goes into the PLC, because I've got 2 or 3 questions about this. And yeah, from the Open PLC project, we have predefined the engineering station with all supported languages, starting from ST language, which is using here in the Labshock. And you can also use FBD or ladder or whatever language which are defined in the EAC standard. And after that, you can change or write your own program. You are compiling it and transferring into the PLC. So it's everything, all the flow from the starting point, from the creation of the program and finishing with the execution on the PLC is inside the Labshock. So you don't need any other tools or any other something, let's say. And you can see here is the names is the same, pump 1 start, work, and it has exactly the same IP, exactly the same addressing. Yeah, this is about engineering station. It's only to show, we are not today talking about how to write programs. I'm only show that it can be done with this service. And let's go into our network. And let's say our normal operations and the operator or engineer is sitting on the screen and trying to create some process that is good for him. And the traffic, you can see this Modbus traffic, which is going from the, let's say, right, which is going from 3.20. 3.20, it is the SCADA system, and it's going into 2.10, this is the PLC. And of course, Modbus TCP. And what I did, I searched for write. So the request is write single coil. So when operator is pressing the stop or start the pump, the first what is going the request from this interface, from this SCADA UI, is going into the PLC. And as we can see, for example, all the oscillator, first of all, there is a packet in binary which contains the layers such as, for example, Ethernet, where you can find the MAC addresses which are talking with each other. And for example, IP layer, which is pretty much familiar to everyone, that 3.20 destination is 2.10. So you can check the normal things from the TCP IP layer. Yes, we can check the TCP, and the destination port is 20502. This is Modbus. And the interesting part is starting from the Modbus traffic. So we have a Modbus. This is Modbus TCP, it's more technical things. And this one is more interesting for us. This is function code. So every command in the Modbus has its own function code. So 5, it is write single coil. The thing that Wireshark or whatever IDS is transferring these function codes into the readable way, for example, write single coil. But in raw data, it's stored as a 5. And this one data, we are sending FF. It means that we send the 1 because it is the endian and reading from the end, but we are sending the 1 into the PLC. And you can find this FF00 also at the end. This is exactly the payload, the data which is sending through our packets. And of course, there is a response. So Modbus is very simple. The SCADA is sending query to the PLC, and the PLC is answering with the response. And in the response, we can also open the IP block. You can see that 2.10 is answering to 3.20. So it's more or less a response that, hey, yes, I changed the value from 0 into the 1. And function code 5, and data is FF00. And that's all. So one command is 2 packets with write single coil and response for write single coil. And the same is happening when we are changing the speed. There is write single register. So let's go one more time into the IP. So we are going from the 3.20, this is SCADA. We are changing the speed. We change the speed and sending it to 2.10, opening the Modbus. The function code is not 5 by 6. 6, it is the write register. Register is storing the integer, some speed, temperature, whatever data. And we can see that data is 21. So let's say we change the speed into the 21. Let's one more time go into the SCADA. Enable this one, go into the SCADA, and let's say change the speed into the 77. Going here, checking the query, Modbus 4D. So 4D, if you are transferring into the endian and decode it into the integer, it will be 77. So that's all. This is the all logic, all the principle of the Modbus. So we are sending response, and after that we are getting we are sending query and getting the response from our PLC. Yeah, of course, there are a lot of more data if you will go into the pickup and the raw traffic, but it is let's say simplified and aggregate it here in the network swiftness. And if we will go into the network, we can see, we can see that it's a common normal state when 3.20 is communicating with the 2.10. So SCADA querying the data from the PLC, and that's all. So 3.1, it is technical things from you can skip it. So and that's all. So it's a good normal state of your network. And of course, now we can try to change values, not from the SCADA, of course, but from the different location. And this is when all the magic happened. So magic is the things that Modbus is, let's say, very simple. So first of all, we are going into the scanning thing. So we need to detect the device that is running the Modbus. How we can do it? First of all, we are scanning the network 2.0, for example, 24. The question is why 2.0? Yeah, you will spend a little bit more time when you are detecting these devices, but in general it can take few hours to scan all the networks, and you will find that 2.0 contains some systems, and we can see that 2.10 is up, and we are going into host scan and can check. First of all, we can check the top ports. This is exactly the wrapper for Nmap. So we are using the Nmap, the version of the Nmap, and we are doing exactly the simple scans for the systems. And we can see that 8080 is open. It's a little bit not interesting for us, and we can write here the range port, and we can detect this 502 is open. So yeah, this is maybe in first view that it's simple to detect the device, but it will take more time in real life. But with these techniques, the adversaries or whatever bad guys are scanning your network and detecting your devices. And because our PLC has no security, no other features to protect from these scans, we are exposing that 502, the standard Modbus port, is open. And we can go into the Modbus client things. So here it is, let's say, the standard client for reading and writing into the Modbus. You can find it on the internet. There are a lot of simple clients existing. So there is no exploits, no something written by the with some crazy logic. No, it's only reading and writing coils. And we can go into this port, starting address 0. Wait a bit. Let's go into the traffic. Yeah, our traffic is collecting, and number of addresses. And what we are doing, we are scanning the first, let's say, 10, 15 addresses for the data which is storing inside the PLC inside these addresses. And after some investigations or some more maybe complex sniffing of the traffic, you can detect that this true at the 0 address is the address and coil which are connecting into the pump. And of course, we can change this address into the full state. We are writing 0 and the pump is switched off. So we can manipulate the pump not from only the UI from the operator station, but also from the different device that is located somewhere on the network. And the good thing, maybe not so good, but we can detect that source 3.30, it's not the SCADA, it's something else, is going into our PLC. And if we will open the packet, you can open the IP and we see not 3.20 but 3.30. So it's something different that in normal life. And when we open the Modbus, one more time, function code 5, the data is 00. So we are sending the same data to address and to the IP of the PLC. And of course, the PLC is responding from (2.10) into 3.30. That here I change my address to the 00 and everything is okay. So I'm not verifying you or authenticate you or doing some security checks. I've got the request, so the query, I'm doing what you are saying to me. And of course, on the network, we can see first 3.20, this is our normal connection. And there is another one who is trying to connect into our 2.10. And this is exactly the thing that you need to understand, and you need to check and configure all these ideas or whatever monitoring tools. But this is a very strict and a very critical thing, that something else is trying to send data into your PLC. But of course it can be do easily, but also detect easily, but of course with some noise. And what else we can do? We can also, let's switch, yeah, traffic is switch back. And the same thing, we can change the registers. Port, starting address 10, running, nothing here. Yeah, we are going next 10, something storing here. So in pretty much I don't know the schema, the addressing of the PLC, but when I'm scanning something, if I see 0000 and after that I'm saying the 77, something is storing on this address. And of course I can try to change it. The address is 10, and value, let's say 11. We are running 11 wrote into the 10. If we are going into the network, let's write, wait for traffic that is coming to the IDS. This is the packets from, one more time, 330 is going into the 210. We can check this. One more time, IP addresses, 330, 210. And in Modbus is the data 0B. B, if you know, B is 11, so we are sending 11 into the reference number. It is the address, let's say. Address 10, we are sending 0B, 11. And what you think, of course, the speed now is 11. And with these manipulations, you can control all your processes. Of course, if it's written not perfectly or expose these critical things with writing coils, writing registers, we can detect all this. And of course, you can do more more complex or more, for example, permanent writes when you are sending into the register address 10 value. I want to fix it to 99 duration seconds. And when I'm sending this to 99, operator is clicking to 23, it go back to 99. And it's very dangerous to your system that, yeah, it's open and you can do not only changing, but changing by time, what we saw in the Stuxnet. You are changing the turbine speed little by little during, let's say, years, and your turbines go out. And you can also mock the outcome. So you will see that not 99 here, but let's say 72. But the turbine will work on the 99. And yeah, this is, let's say, very, very dangerous of this Modbus, which is simple, but on the other hand, not secure. And of course, the one thing is to segment this network that no one can access into 2.10. This is the only one thing what you can do with Modbus, and or of course change it to some OPC UA. This is all about the Modbus. One maybe more thing what I wanted to show. The last service is the logs, which you can also gather, for example, login attempts, or reading the settings, or changing the PLC. It's not maybe related to the Modbus, but when you connect your PLC into the collector and into the monitoring systems, it will gives you a lot of interesting information without a noise, what you can see on the network. So to detect that someone logging into the PLC, it's not simple task to SOC analytics or to security officers or whatever. But if PLC is sending logs such as logins or reading or writing, you will know that when your engineer changing the PLC or the text or something into your PLC. Yeah, that's all. Maybe my idea, or maybe let's say with Labshock is to reduce the time. For example, here we talk about one lab, and to reduce this time into the 40 or maybe less minutes, that you have everything in your, let's say, pocket, and all the services, and you can work and show to people that this is the Modbus, this is